Hi everyone, Mrs. Schmidt here, taking a look at our math homework. We are looking at lesson 3 in module 6. Our lesson summary today, it reminds us that we're looking at our rate of change, B, and an initial value, A, are given in the context of a problem. The linear function that models the situation is given by the equation y equals a plus bx. Now this looks a little different than what we're used to, and I don't want you to panic when you see that, because essentially it's what we've been talking about this whole time, which is y equals mx plus b, where b is your constant or your initial value, and m is still your slope or your rate of change. They're really, for lack of better terms, they're really just throwing other variables at us. And remember, variables are the letters of unknown values that represent something. So just keep all of that in mind. The rate of change and initial value can also be used to sketch the graph of the linear function that models the situation. We've been talking about this the last few days. It's important that you realize that you can have an equation that represents a scenario. You can also put that scenario on a graph or even a table. So you might have a problem that says write the function that relates to this graph, or gives you a word problem and says write the function or graph the scenario. So you just need to know the difference between all of those things. When two or more ordered pairs are given in the context of a problem that involves a linear relationship, the graph of the linear function is a line that passes through those points. The linear function can be represented by the equation of that line. What you need to know, I know that's a lot, but what you need to know is that linear functions make straight lines. So our data that's on our graph or in our table, those data points, or those ordered pairs on the graph, are going to fall on that line. And we know that because it's a straight line. A linear function, I'll write that down. Linear means straight. Nonlinear means not straight. So anything that's not straight is non-linear. This prefix means not. Okay, so let's actually, now that we reviewed that, let's actually look at number 1 of our problem set. It says here, number 1, a plumbing company charges a service fee of $120 plus $40 for each hour worked. I'm going to read that one more time. A plumbing company charges a service fee of $120 plus $40 for each hour worked. Now, there's a lot of important information there. I'm going to highlight just a few things. They have a service fee of $120. That's important. Another thing that I see that's important is this plus. Think back to your math key terms. Oh, I'm blurry. Think back to your math key terms. The word plus means, that's right, plus means addition. Okay, and then we know that it's $40 for each hour worked. $40 for each hour worked. Okay, now that we pointed out those important parts, sketch the graph of the linear function relating the cost to the customer in dollars. C. So your dollars it wants to represent by C, which is your total dollars, your total cost. So I'm going to go ahead and write a C over here. To the time worked by the plumber in hours, T. T for time, C for cost. That's what they're doing here. On the axis is below. So you have your cost in dollars, which is your C value, and your time in hours, which is your T value. Okay? So when we look back at our important information here, it says a plumbing company charges a service fee of $120. So just to get this plumber to come out to your house because your toilet is clogged or your sink won't drain, sounds like Mrs. Schmidt's house right now, but whatever it is, $120 just to get the plumber to come out. So your cost in dollars, your initial value is $120. If you look, this graph goes by 20, 40, 60, 80, 100. It goes by 20s. 20, 40, 60, 80, 200. So I need to find 120, and I need to put my initial point right there. That is my starting point. And then I need to go up. For 1 hour of work, I need to add $40 because for each hour worked, it's $40. So for 1 hour, it's going to be 120 plus 40, which would be 160, which is right there. At 2 hours, I'm going to go up 2 more spots, which is 200. And then at 3 hours, I need to go up 2 more spots, which is 2. Let's make sure I do that right. 120. Yes, right there. So you need to keep going, and you go all the way up to 6 hours. But every time you go up $40 because each hour is $40. Now I'm going to throw a curveball at you. Think about this. If he worked for an hour and a half, so it'd fall right here between an hour and 2 hours, you're probably going to get charged for that half hour. And you would have to look at what is the rate of a half hour of work. Well, if he gets paid $40 an hour, a half of that would be 20. So just keep that in mind. This is like I always say, real life stuff here. I am going to go ahead and graph the rest of this. I'm going to go up 20 more. It's really tiny, I know, you guys, but make sure you're counting it out so that you really can visualize the cost of this plumber. Hey, but your toilet's going to get fixed, so that's okay. Okay? And if you look, I have a straight line. It's not perfect, but it's straight. A straight line for my data. So, I took care of that. I sketched the graph of the linear function. Read your directions. Every single point in this problem should be covered. So if you look at A, it says, if the plumber works for 0 hours, what is the cost to the customer? How is this shown on the graph? Well, if you look, we already talked about it. Just to come out, even if he doesn't work for a single minute, just to come to your house for 0 hours, he's going to charge you $120, which is our initial value, and it's right there. Remember, we're talking about initial values and rate of changes. So $120, and it's shown on the graph by this point right here, which is 0, 120. So I'm just going to make a little note, 0, 120. That tells me you understand what the cost is. It's 120, and it's shown on the graph by being reflected at that point. Okay, let's look at B. What is the rate of change that relates cost to time? So what is your rate of change? What is your slope? Rate of change and slope are the same exact thing. It's how much it's changing from point to point. So for 1 hour, it's at 120. At 0, it's at 120. And then if you add that 40, it's at 160. So how much does it change from point to point? It's $40 because it's $40 for each hour worked. $40. Okay? Now C wants us to write a linear function that models the relationship between the hours worked and the cost to the customer. A linear function. This is asking us to write an equation that models this relationship on our graph between the cost in dollars and the time in hours. So when you're looking at this, it already told us up here that our C represents our total. Now, like I wrote up at the top, y equals mx plus b. Don't ever forget that for linear equations. They're just making it super complicated by giving us different variables. But C is your total cost. So C, we know, is going to be in place of our total, which is our y. Our m is our slope, which is our rate of change, which we already determined. Here is 40. So instead of m, I'm going to write 40. And then our x is our input, which we don't know. We don't know the total hours each time. So we leave that as x so we can input it to do our calculations. And then we need to add that initial value of 120. It's 120 just to get the plumber to come out. So there we have our linear function or our linear equation that models this graph. That models the information given. Now let's look at D. So we've done A, we've done B, we've done C, we're on D. Find the cost to the customer if the plumber works for each of the following number of hours. Now if you look back here, I'm going to make you a little note in a pretty blue color. C is your cost, your total cost. X is the number of hours. And this question here is asking us for 1 hour, for 2 hours, and for 6 hours, what is the total cost? So the first thing you're going to do is instead of, you're going to rewrite your equation, and instead of your x, you're going to replace it with each of these values. C equals 40x plus 120. I want you to pay attention to how careful I am about lining everything up. It'll help you keep track of your equations and keep track of your problems. So instead of an x here, I'm going to plug in a 1. C equals 40 times 1 plus 120. To solve this, the first thing I'm going to do is do 40 times 1. 40 times 1 is 40. I'm going to add 120 there. Remember, line it up so that you don't lose track of any of your numbers. They're all important. 40 plus 120 is 160, which makes sense because if you look at what we already graphed for 1 hour, it is 160. Okay, so I want you to do 2 hours and 6 hours on your own. I don't want to give you too many answers, but 2 hours and 6 hours. Do it just like we did this one. Instead of your x, you're going to plug in 2 and you're going to solve, and it should line up with what you have in your graph. So E wants us to plot the points for these times on the coordinate plane and use a straight edge to draw the line through the points. A straight edge is a fancy word for ruler, so don't let that confuse you. But it's saying to plot the points for these times on the coordinate plane. You already have that right here. So all I want you to do at that point is take your straight edge, we'll be fancy and call it a straight edge, then create your line. Okay? And as long as you did those other two equations and you solve those, you are done with number 1.